Myself, Madhuri Modak, Assistant Professor in Mathematics, Department of Computer Science, Aveda Inamdar, Senior College. Now, in the paper Discrete Mathematics, now the first unit of Discrete Mathematics is Logic and Mathematical Induction. For computer science students, this unit is very important. Negation. Now, the third point is argument in propositional logic. Validity of an argument, direct and indirect methods, rules of inference for propositional logic and grading arguments. Now, first we will see definition of argument in logic. Now, in real life also, we do arguments with each other. So, what is argument in logic? An argument is conclusion justified by premise, means hypothesis. So, we have to justify the conclusion by using the hypothesis, that is given things or known things, that is premise. Where conclusion is a proposition which is claimed to be justified, and hypothesis is set of propositions which are used to justify the conclusion. So by taking the support of that premise or hypothesis, we have to justify the conclusion. Now, if P, P1, P2, Pn is premise, means these are given things, hypothesis, and C is conclusion justified by premise, then how to write argument P, P1, P2 yields C is called an argument. Now this symbol is read as yields. Now an argument is also written as, first we write P1, P2, Pn all the premise or hypothesis, and then the below C as a conclusion. Now when we say that this argument is valid and invalid, see, an argument P, P1, P2, Pn yields C is said to be valid argument if P1 and P2 and P3 and so on and Pn implication C is a tautology. Otherwise, argument is said to be invalid or a falsy. Now, what is the meaning of P1 and P2 and Pn implication C is a tautology? Now, tautology means in the truth table of P1 and P2 and Pn implication C, this last column values must be all true. Now, in case of implication, whenever antecedent is true and conclusion is false, then we get the value as false. But if there is no case that antecedent is true and conclusion is false, then in that case we get all the true values. So if it is a tautology, it means P1 and P2 and Pn is true and conclusion is false. That case is not possible. It means P1, P2, Pn are true and conclusion is not false. Then in that case the argument is valid. It means from P1, P2, Pn we are getting C as a conclusion in our words. Then the argument is valid argument. But if it is not a tautology, then in that case it is an invalid argument. Thus, an argument is invalid if premise P1 and P2 and Pn is true, but conclusion C is false. That means even though P1, P2, Pn all are true, we are getting conclusion C as false. Then in that case, the argument is invalid. Now, methods to test validity of an argument. Now, the first method is validity using truth table. Now, already we have seen how to prepare the truth table for given statement. Now, see, consider P, P1, P2, Pn yields C. Now, this is the argument in symbolic form. Now, if we want to check its validity by using truth table, then we have to prepare the truth table of P1 and P2 and Pn implication C, because by definition if this is a tautology then argument is valid, otherwise it is invalid. So just prepare the truth table for P1 and P2 and Pn implication C. If this column contains all true values, means it is a tautology, then argument is valid. Now see one example by using this method. Test the validity of following argument by using truth table. So P double implication or by implication Q yields P. Now whatever written to the right of yield symbol is the conclusion. So in this case conclusion C is nothing but P. Now, this is one hypothesis, this is another hypothesis. So, you can consider this as P1 premise and this as P2 premise. So, according to this, we have to prepare the table as P1 and P2 implies C. So, P by implication Q yields P is valid argument if and only if P1 and P2 implication C means P by implication Q and Q implication P is a tautology. Now the basic part is prepare the truth table for this. As there are two variables P and Q, there are four rows. Now the columns will be like P, Q, then P by implication Q, then P by implication Q, and then P by implication Q and Q implies P. Now by using the standard truth tables, we are getting that last column as all T. Means it is a tautology and hence by definition, this argument is valid argument. Now one more example. Now test the validity of following argument. If it rains heavily and there is high tide, then the roads get flooded. There is a high tide, but the roads are not flooded. Therefore, it has not rained heavily. Now, here the argument is not given in symbolic form. So, first we have to assume the statements in terms of propositional variables and convert it into symbolic form. Now, what are the different statements used here? It rains heavily. There is high tide. The roads get flooded. Now, if you define some variable for roads get flooded, then you can write its negation easily. So, don't take separate variable for that. So, there are three different statements. We assume P as it rains heavily, Q as there is high tide, R as the roads are flooded. Now, how to write symbolically? If it rains heavily and there is high tide, then the roads get flooded. Now this is P, this is Q, this is R, and this is implication. So here P and Q, and it implies R. So first is P and Q implies R. There is a high tide, but the roads are not flooded. So there is a high tide means Q, but is same as and. So Q and not flooded. So it is negation of R. So second statement can be written as Q and negation R. Now, therefore it has not rained heavily. So the thing it has not rained heavily is nothing but the conclusion. So we have to write it after yield symbol. That not rain means it is negation of P. So this left hand side is nothing but our premise part, hypothesis part, and this right side is nothing but conclusion. So this is one premise, we consider it as P1 and this as P2 and this is our C. So again by using truth table method, P1 and P2 implies C. If it is a tautology, then the argument is valid. Otherwise, it is invalid. So P1 is P and Q implies R, and P2 is Q and negation R implies C is negation P. So if it is a tautology, then the argument is valid. Otherwise, not. Now there are three variables P, Q, R. So truth table contains 8 rows. Now we prepare the truth table. So P, Q, R, then P and Q, negation R, P and Q implication R, then Q and negation R, then conjunction of these two that is 6 and 7, then negation P which is conclusion, then 8 implication 9 because 8 is nothing but this left hand side and 9 is nothing but right side. Now in the last column we are getting all true values after preparing the truth table. It means it is a tautology, hence given argument is valid. Now, even though truth table method is very easy because making truth table is very easy part. But the main thing is that if there are only two or three variables in the argument, then That table is very easy because it contains only 4 rows or 8 rows respectively. But many times the argument contains 4 variables or 5 variables. See, if the argument contains 4 variables, then there will be 2 raised to 4, that is 16 rows in the table. If argument contains 5 variables, then table contains 2 raised to 5, that is 32 rows in a table. So it is very difficult and time consuming to prepare that table, and even there may be some mistakes while preparing the table. So even though this method is very easy, it is not applicable practically if there are more than 3 variables. So we are not using this method that much. Instead of that, there are two other methods that we have to study. One is direct method and another is indirect method. Now we have seen the definition of argument, and what is the meaning of valid argument and invalid argument? Now there are various methods to test the validity of an argument. Now one method we have seen, that is truth table method. So the method is very easy, but if the number of variables are greater than or equal to 4, then it is quite difficult to prepare the truth table. Hence, we are not using that method that much. Now, second method is direct method, that is using rules of inference. Now, to test the validity of P, P1, P2, Pn yield C, consider premises P, P1, P2, Pn. Apply some rules of inference. If we get conclusion C, then the argument is valid. Otherwise, it is invalid. It means from P1, P2, Pn hypothesis given to us, if we are getting conclusion C logically by using some rules of inference, then the argument is valid. Otherwise, it is invalid. Now, see what are the rules of inference for propositional logic, which we are using in direct and indirect method. Now see, these are some rules of inferences. So these are standard rules. So how to apply them by testing the validity of argument? For that, you have to consider what is the left side part of that yield symbol. That is nothing but a hypothesis or premise. So such type of hypothesis or premise is there, then definitely from that hypothesis or premise we get the right side conclusion. Now the first is P. P implies Q yields Q. It means whenever P and P implies Q, these two premises are given to us, then from that Q always follows as a conclusion. So this rule is known as detachment or rule of modus ponens. Now second is negation Q and P implication Q. So if these two premises are there, then from that negation P conclusion always holds. It means these are all valid arguments. So whenever left hand side hypothesis is there, always we get the right side as a conclusion. Now this rule is known as contrapositive or rule of modus tollens. Now third one, P yields P or Q yields P or Q. It means whenever P is given as hypothesis or Q is given as hypothesis, then from P or Q we get P or Q as a conclusion. Now this is known as disjunctive addition or rule of addition. Now fourth one is P or Q negation P yields Q, or P or Q negation Q yields P. Now this is known as disjunctive simplification or rule of disjunctive syllogism. Now next is P and Q yields P or P and Q yields Q. It means whenever P and Q statement is there or hypothesis is there, then from P and Q we get always P as well as Q. So this is known as conjunctive simplification or rule of simplification. Now next one is chain rule. P implies Q, Q implies R, yields P implies R. Now this is known as rule of hypothetical syllogism also. Now next is rule of exportation. P and Q implies R. That yields P implies Q implies R. Then rule of importation. P implies Q implies R. Here is P and Q implies R. Now, conditional equivalences. So P implies Q is logically equivalent to negation Q implies negation P. That is its contrapositive, which is logically equivalent to negation P or Q. So sometimes we need to use these logical equivalences while checking for validity of an argument. Then P by implication Q is logically equivalent to P implies Q and Q implies P, which is logically equivalent to P and Q imply P and Q or negation P and negation Q. That is biconditional equivalences or material equivalence. And last is resolution. P or Q negation P or R yields Q or R. But mostly while using rules of inferences, the important rules are from 1 to 6. We are using mostly rule numbers 1 to 6. So remember rule of inferences with their name, because whenever we are using some rule at that time, it is necessary to mention name of that rule. Now, see first example. Now, before checking the validity of an argument by using direct method, first we will see some simple examples in which we have to state what is the rule used. Now, first one, write the following argument in symbolic form and give the name to this rule. It is below freezing now. Therefore, it is either below freezing or raining. Now here two statements are there. One is below freezing now. Second is raining. So we need to consider two variables. Let P it is below freezing. Q it is raining. Now we write the given argument in symbolic form. It is below freezing now. It is nothing but P. Therefore, it means it is the conclusion obtained from this hypothesis. So what is the conclusion? It is either below freezing or raining. So below freezing is P or raining is Q. So it is P or Q. So P yields P or Q. That is the argument in symbolic form. So P yields P or Q. That rule is nothing but rule of addition. So here we have stated what is the rule of inference used in argument. Now see second one. What rule of inference is used in each of these arguments? Jerry is a mathematics major and a computer science major. Therefore, Jerry is a mathematics major. Again, first we write the argument in symbolic form. There are two statements. We need two variables. One for mathematics major and second for computer science major. Let P Jerry is a mathematics major and Q Jerry is a computer science major. Symbolically, we write the given argument as this is P, this is Q joined by logical connective AND. So P and Q. Conclusion is Jerry is a mathematics major. So P and Q yields P. Now here the rule used is rule of simplification. Now, second one. If it snows today, the university will close. The university is not closed today, therefore, it did not snow today. Now, first we assume the variables to represent the argument in symbolic form. Let P, it snows today. Q, the university will close. Now, in symbolic form, this is P implication Q. Not closed is nothing but negation of this Q. So P implies Q, negation Q, that yields did not snow today. So it is negation of P. So P implies Q, negation Q yields negation P. That is the argument in symbolic form. So here the rule used is rule of modus tollens or law of contrapositive. Now, next example. Test the validity of following argument using direct method. Now, P or Q, Q implies R, P or Q, P implies R, negation R yields Q. So, this is the argument given in symbolic form directly. Now, in direct method, we start with the premise that is hypothesis. So this left hand side part is our hypothesis or premise and right side Q is the conclusion. So we start with hypothesis or premise P or Q. P implies R, negation R. Now here I have underlined for the premise for which we are applying some rule from the table of rules of inferences. Now here for P or Q, P implies R, there is no rule in the table. But if you observe second and third one, P implies R, negation R. So here in this implication, R is the conclusion and its negation is given there. Now the rule is P implies Q, negation Q is there. Then from that we get negation P as a conclusion. Instead of Q, only R is written. So it fits in that format of rule of modus tollens. So by rule of modus tollens, we can replace this premise by negation P because it is the conclusion obtained from these two premises. So we got P or Q negation P. Again, there is one that a rule that P or Q negation P that gives us Q because P or Q means either P or Q will happen. At the same time, negation P means not P is there. So if P is not happening, then definitely Q will happen. So by disjunctive simplification, we get Q. And Q is nothing but the right side, that is conclusion of the argument. Hence, from the hypothesis or premises, by using rules of inferences, we reached at the conclusion. Hence, the given argument is valid. Now next is test the validity of following argument using direct method. So again this left side part is the hypothesis or premises and the right side T is the conclusion. So we start with the premises. Negation P and Q, R implies P, negation R implies S implies T. Now here again if you consider first, second, we can't use any rule. Now second, third, fourth, all these are implication. So whenever two or more implications are there, first see whether we can apply chain rule or not. That is P implies Q, Q implies R, that here P implies R. But here it is R implies P and here it is starting with negation R. So for these two we cannot apply chain rule. But if you consider second and third in that implication, then here we can apply chain rule. Or you can consider negation P and Q as negation P, Q separate also. So there are many ways to apply the rules. It depends on the person. Someone can use directly chain rule for these two implications or someone can split this. So you can do it in any way, but finally we get the same part T as a conclusion in this case. Now here for negation P and Q, from these two we get negation P comma Q and the remaining premise part is same. So here we have used conjunctive simplification. Now see negation P comma Q R implies T. Negation R implies S implies T. So this is our hypothesis. Now R implies P is logically equivalent to negation P implication negation R. So here we have used that logical equivalence and remaining premise part is same. Now second and third implication, here we can use chain rule. So by chain rule we can replace these two premises by negation P implies S and remaining part is same. So we get negation P implies S implies T and Q also. Then again applying chain rule for these two, we get negation P implies T. Now negation P is already there, negation P implies T is there. So by rule of modus ponens, we get T finally as a conclusion. Hence the given argument is valid. Now, third method is indirect method, that is method of contradiction. So in mathematics, many times while proving some theorem, we start with whatever we have to prove negation of that statement. For example, if we want to show that root 2 is an irrational number, then what is the method of showing that root 2 is an irrational number? We start with the negation of that statement. That means root 2 is a rational number. Then by applying the things in mathematics, we get somewhere contradiction. So why we are getting contradiction? Because we have started with the wrong assumption that root 2 is a rational numbers. So this method is known as indirect method. So whatever you want to prove, you have to start with negation of the conclusion. Now see indirect method. To test validity of P, P1, P2, Pn yield C, consider P1, P2, Pn and negation of C. So here C is the conclusion. We are starting with all hypothesis or premise together with negation of the conclusion. Apply some rules of logic. If we get contradiction in simplification, then given argument is valid. Otherwise, argument is invalid. Now see first example. Test the validity by using indirect method. P or Q, P implies R, negation R yields Q. Now here we start with all the hypothesis or premise together with negation of conclusion. So Q is conclusion, we start with negation Q and all hypothesis. So P or Q, P implies R, negation R, negation Q. Now see these middle statements. P implies R, negation R. So by rule of modus tollens or by contrapositive we get negation P as a conclusion. So P or Q remain as it is, negation Q as it is, and from second, third we get negation P. Now for second and third, P or Q negation P, by using the rule we get Q as a conclusion by using disjunctive simplification, and negation Q is already there. So we are getting Q negation Q at a time. But whatever is the statement Q, if Q is happening, negation Q cannot happen. If negation Q is there, then Q cannot be possible. So Q negation Q cannot occur at a time. But here Q and negation Q are occurring at a time. So contradiction. Hence given argument is valid. Now see second example. Prove validity of following argument by method of indirect proof. If Meena marries Rohit, she will be in Nashik. If Meena marries Tanmay, she will be in Baramati. If she is either in Nashik or Baramati, she will definitely be settled in life. She is not settled in life. Thus, she did not marry Rohit or Tanmay. So, whatever is given after hence, therefore, thus, it is nothing but the conclusion. So, in this case, the conclusion is she didn't marry Rohit or Tanmay. Now, considering the different statements, we have to consider the variables. So, here, let R, Meena marries Rohit. So as the name is Rohit, we are considering it as R. Then N is Meena will be in Nashik. T, Meena marries Tanmay. B, Meena will be in Baramati. S, Meena is settled in life. So whenever you have to write some negation of any statement, then you can use negation R, negation N like that. So no, not necessary to consider it as separate variable. Now symbolically we write the given argument as, now Meena marries Rohit, she will be in Nashik. So Rohit means R and will be in Nashik means N. So first is R implies N. Then Meena marries Tanmay. So Tanmay means T, she will be in Baramati. So T implication B. Next, if she is either in Nashik or Baramati, she will definitely settled in life. So, Nashik or Baramati, it means it is N or B. It implies settled in life, that is S. So, N or B implication S. Then not settled in life, that is also given. So, it is negation of S. Thus is nothing but the conclusion. Yields she did not marry Rohit or Tanmay. It means she did not she married neither Rohit nor Tanmay. So neither Rohit nor Tanmay means negation R and negation T, or you can write simply negation R or T. So this is the argument in symbolic form. Now we have to use indirect method. So we start with hypothesis together with negation of the conclusion. Now here conclusion is negation R or T. So negation of that part is R or T. So this entire part is our hypothesis and this is the negation of conclusion. Now see these two statements, N or B implies S and negation of S. Again, by using rule of modus tollens, we get a conclusion as negation of N or B, and the remaining hypothesis part remain same. Now, R implies and T implies B. Negation N or B we have kept as it is. Now, from R or T we get negation R implies T. Now in next step, see, this is T implies B, this is negation R implies T. So we can use chain rule. So from these two we get negation R implies B. Now this part is same, R implies N as it is. Again, R implies N is logically equivalent to negation N implies negation R. Then this is negation R implies B and negation in bracket N or B. Again by using chain rule we get negation N implies B here and this is negation of N or B. Now this is nothing but N or B because N or B and negation N implies B are logically equivalent. So we get this as N or B and negation N or B remains as it is. Now N or B, negation N or B are occurring at a time. So contradiction. Hence given argument is valid.